In this video, I will show how to use the new program, the new version of the program, the new release, and as well I will demonstrate a little bit how to work with new type of files that are available as raw data or acquisition data or sources for this program. So this is the program. It was launched from here, from the standalone distribution. So in case already prepared standalone distributions available via the link do not work on your computer, you can also follow the link in the description of this video where there is a full guide on how to install this program on your computer from the Python files. Here we will start from here, and first of course you have to import. And to import you have to go to your files where they are here, and here we have some txt files, and here I have two types of experiments. So first of all, those are large unilamellar vesicles labeled by Nile-Red-12S. We will start with those. And here are three files representing data from vesicles that were prepared from DOPC, POPC, or POPC cholesterol. I will open all of them together. And this will take a while. The problem here is that the files are huge, and what is program doing right now? It is extracting data from files, but also compressing them and preparing new files. What does it mean, new files? So if we go to the folder where the data is, we can go over here, and you see that there is already for DOPC the new file prepared. So this is file DOPC SPP corrected.csv. So this CSV file, all three of them by the way are already prepared. This is file which is already compressed, and when you are going to open this data next time, you can use these new files in .csv format, where the import will be much faster. In any case, here everything is already done. So what we can do, we can we can also do the diffusion analysis, but diffusion analysis is no different from what was done before in the previous version. So I will focus here on peak analysis, and peak analysis here is looking a little bit different now. So what is going on here? I added some new functionalities to the analysis, and here I also added some sectioning over here in case you would like to categorize certain functions that this program can do. And here, for example, when you open display, here is what you want to show. So what you want to show here, maybe you just want to show trace for channel 1, or maybe just trace for channel 2. You can also see that there are several channels here. Right now it's channel 1, channel 2. There can be more channels, and then you can use binning. This is the same as in previous version. So here, since this is imported from the txt file, the whole trace is imported at once. And if you want to divide this trace into more traces, so to say, into more repetitions, what you can do, you can go here into the restructure data and change number of repetitions in case you want several histograms, or in case you want, for example, some time-lapse data or something like that. Then here is what else did I miss here? Yeah, display peaks. So here, pretty much if you click this, it will show you which peaks are detected. Of course, right now it's a mess, but what you can do, you can just, yeah, increase here, it will show you which peaks are detected. Here, histogram is this thing. So this is GP histogram, this is peak intensity histogram. And right now it's peak intensity, so what you do, you can show prominences, for example. And now it will say peak prominence, the histogram, and so on. Peak widths as well here. So we come back to peak intensity. So our GP histogram is true here, so we then close this and then we go to detect peaks. So when you detect peaks, again, you use certain channel for detection. This all right now doesn't work. There will be a separate patch to choose which channels do you want to use for detection in case you want to use more than one channel. Right now it's either channel 1 or channel 2. And then you have thresholding via manual or via z-score. And z-score means that you have to set which z-score of this trace will be taken as the threshold. And here you can select if it is channel 1. Let's select it again, maybe to 3, so we update threshold. And you see that number of detected peaks decreased because we set the threshold a bit higher, well, set it lower. What will happen? It should increase substantially. Yes, here is a lot of points, but I will go back to 2. It's a comfortable z-score for peak detection. In any case, the GP histogram doesn't change much when we go from 1 to 3, meaning doesn't change in terms of center. Number of particles, of course, changes. Next one. This is peak statistics. So what is peak statistics? This is useful in case we want to quantify something for example, protein binding. In this case, here it's not that useful, but what pretty much it says, first it says how much peaks in this channel are detected. Of course, since we use one channel for detection, in every channel will be the same number of detected peaks, because we use channel 1, we detect 5,205 peaks in channel 0, it's the same as channel 1 here. And then here 5,205 again, because this is the same number of peaks, but in the second channel only this number of peaks is above the threshold. This is important sometimes. In this case it's not that severe, but if you, for example, want to check how much particles have, for example, protein coverage or certain cargo in them, this is sometimes very useful to check. Okay, what's next? Now GP calculation. GP calculation is everything about this GP histogram. And here when we open it, it now looks substantially different from what we had before. In particular, you can select which channels do you use for blue and red channels for GP histogram. So if you remember, GP has a certain formula, which is intensity in the blue range minus intensity in the red range divided by the sum of intensity of blue and red ranges. But sometimes what we want just to reverse it. So what we do, we say that blue range will be actually in channel 2 and red range will be in channel 1. So what happens here, it is completely opposite. It's instead of minus 0.6, it's at plus 0.6. Sometimes it's useful. Sometimes if you have more channels, you can select, for example, sum of channels to be included into the blue or red ranges, and that's what you want. We will go back here, because this is our usual formula that we are using. And here is also interesting thing, which is subtract blue background, subtract red background. So blue and red is referred not to whatever you have over here, but blue means blue channel. If you select as blue channel 2 here, it will anyway subtract from here, from this blue one. And red the same over here. So this is sometimes useful if you have protein binding and then you have high background over here. This will be a bit later in the video when I will show how to process protein binding to the LUVs. And last but not least is fitting. And here what we can do, we can fit our distribution, fit this, and this will show you the Gaussian fit. You can have several components and so on. Then you can save this data, everything which is here, including traces. Traces I don't want to save right now because well, it's a lot of data and it will take a lot of time. So I will disable traces here, but everything else I will save. So I click Save Plot Data. And yeah, hopefully everything worked. Yeah, so here is the XLSX Excel file. You can try to open it. Looks legit. Come on. Yeah. Okay. Anyway. So here is the file. And what is in this file is a lot of tabs. So in first tab you have intensity peaks. If you want to save traces, here will be additional tab in the beginning that will contain full traces, which will be a lot of data again. You have intensity peaks, then the same for prominences, the same for widths. Then you have histograms. So histograms are for whatever histograms are displayed. So it's not histograms for all of them, but now having all the prominences and widths, you can also construct new histograms in whatever software you choose to use. Then we have our dot plot, so channel 1 versus channel 2. And then we have our GP plot. So here is the GP list of all GP values in case you are not happy with the histogram and want to produce the new one. Here is the GP histogram that was produced via the PyProfiler, and the next is the fit. Then there are fitting parameters, amplitude, mean value, and sigma, and also there are some score parameters. So this is often useful in case you want to compare different fitting modalities, so to say. In case you want to fit it differently a couple of times and then check which fitting fits better, you can check these scores. And usually, what is it? The lower the score, the better the fit. And at the end, we have the, well, quote-unquote metadata. And metadata shows in which well, that's first of all the threshold, which was applied to two different channels, channel 0, channel 1. And here is also number of peaks detected in this channel, and again number of peaks above the threshold over here. So this is sometimes useful. Okay, so that's what we did for different liposomes. Ah, yeah, okay. I haven't shown you what is going on in different liposomes. So this was POPC, I guess, and then when we move to POPC cholesterol, you can see that it's already shifted to the right, and DPPC, oh my god, DOPC. This is DOPC, and the OPC is shifted to the left. So you can fit, for example, the OPC, it's minus 0.71. If we fit it before POPC, and POPC is centered around minus 0.63, and POPC cholesterol, if we fit that, it's minus 0.51. Maybe even here it probably would be even better to, I don't know, maybe use two-component fitting to fit it better. Okay, so as I said before, we can import the same data but from CSV. So here we can open CSV, and then when we open CSV, it should work much faster and show pretty much the same data. Yeah, this worked much faster than TXT files. Okay, so what happens next? I will show a different analysis, which is about protein binding. So here are few important things. So first of all, we have files that contain data on protein binding to LUVs, but we also have files where we have just the protein itself in the solution. So this is important also to have these proteins in the solution, because from there we can quantify molecular brightness and later quantify how much protein do we have per particle. Here we have a lot of files, which might work slowly again. You can see that these CSV files are being generated one by one. This means that the TXT files are processed. And we wait until everything is imported. Yep, everything is here. So first of all, before we move to the LUVs, we can go towards the diffusion of the protein in the solution. So what you can see here, for example, this is the Shiga toxin protein, just dissolved in PBS. And here is the correlation curve from this measurement. And you can go to the diffusion analysis. And despite the fact that this was recorded not with the FCS mode and even not with the photon counting mode of the detector, this is in the integration mode, the correlation curve is pretty decent. And what we can do, we can fit. So how do we fit? So here offset is clearly 0, we can fix it at 0. Then Gn0 we actually have to extract. We have only one population, so A equals to 1. This will leave, so this is free diffusion 100%, so alpha should be 1. Aspect ratio I will fix here to 7, but you have to take it from your calibration sample. B we have to actually extract, and to be honest here, since we are done at 10 to the minus 4, triplet should go to 0. That's it. No triplet. We have no time resolution to be able to see what is happening in the triplet range. So then I can click fit, and something is fit, so I'm not 100% happy with this fit. Maybe if you want to have better resolution over here, you should select smaller time step in your spot SPP. Yeah, by the way, I have made the recordings on how to record spot SPP. Description is also contains the link to that video. In any case, here we have our diffusion, which is okay. Diffusion time for the protein. And then we also, what we have number of proteins and molecular brightness of the protein. So this is very important because this value will actually tell us what is the intensity of one single protein. And now when we move to the analysis of protein binding to LUVs, we will be able to convert our brightness to the number of proteins. So how do we do that? Now we close here, we go to the peak analysis. And within the peak analysis, we have to select something that has Shiga toxin. Let's say this one. So you can see 2 channels, channel 1, channel 2, Shiga toxin is in channel 2, liposomes are in channel 1. And what you see over here, you actually see the intensity histograms. And this is what we are interested in. We have to look at the intensity histograms, and then this intensity histogram we will export and then convert it into the number of particles. But one interesting thing is also here in the GP histogram. So GP histogram from the first point of view makes no sense here, because this is not the ratiometric probe. This is these are 2 different dyes that are just happening to be on one liposome. But in any case, GP is ratiometric measurement, right? So we can go here to the GP calculations. And first of all, what I would do, I would switch here like this. So what you do, you move your GP histogram to the left, and then I would subtract the background over here. So now what you can see is very interesting. You again see the GP histogram, but in a way that you have 2 populations over here pretty much. So one population corresponds to something which has very low signal in the channel 2 and just normal signal in the channel 1. These are liposomes that do not contain protein. Then you have second population over here that has higher intensity over here. This means that there is some protein over there. And in addition to this histogram over here, this is again some sort of nice representation on what is actually happening in your sample. And then this GP histogram we can fit with, well, 2 components maybe. Let's select 2 components here. So I will just put it 0 as an initial value, and when you click fit this, still didn't work so well. Why? Because this went to -1. I want it to be somewhere here. I would do this again. Yeah, sometimes you have to help it a little bit to -0.6, let's say. no, even less. Yeah, something like this. And then no. Maybe I can make that population a little bit more pronounced by including a little bit more liposomes. Yeah. Maybe here. Yeah, this will of course do the same. Yeah, this looks better. Okay, so anyway, two-component fitting works here, and yeah, we can check similar thing, for example, for this sample. This is cholera-toxin bound to LUVs. So here, that's what you have. Background subtracted. Here are yeah, of course, that's what it does. Yeah, like this. So here you have again two populations with more and less protein, and it will show you what it actually is in your sample. Okay, so that's what the new version of the program can do. It can import TXT files from Spot SPP, and then it can convert them into the CSV if you want to reanalyze it without waiting as long as you want. And then later you can save this data in Excel file here by save plot data. And then you can use the data to construct your figure or for further analysis.